So I'm going to get straight into it. You can have a read of the questions here if you like, or the context of it, but I'm going to detail the calculator processes, both processes, because we'll learn two. So let's have a read of the question. The probability that a seed will germinate is 0.85. So we have two possible outcomes. It's either going to germinate, that means it's going to grow into a plant, or it's not. Okay? And so it's likely to grow into a plant. We're planting 6 seeds in a pot, so n is 6. Alright, and so we can say x, the random variable, the experiment, is binomially distributed with 6 trials, and the probability of success is 0.85. So part A, calculate the probability that exactly 5 seeds will germinate. So here we're calculating the probability of x being equal to 5. Now we did this yesterday, in that we could use the binomial distribution formula. That's where we would go 5 successes out of 6 trials. The probability of success is 0.85 to the power of 5, and the probability of failure is 0.15 to the power of 1. Okay, so you can do that. We need to recognise that's one process. But now there's 2 ways we can do it on our calculator as well. So let's explore both of those. I think the easiest way is to go into stat. Okay, so maybe pull your calculator out, follow along here. So stat, we're going to go F5 for distribution. So stat distribution, and we're talking about binomial, which is F5 again. And then I've written this up here. We've got Bpd is for an exact outcome. Bcd is for a cumulative outcome. That means when it's not exact, that'll pop up in a moment. So let's go to Bpd, and your data, did I press the right one there? I pressed Bcd, excuse me. Distribution, binomial, Bpd, which is F1. And your data is variable, should be variable, nothing to do with your lists. So if it says list, change it to say variable. X is the number of successes. So it's popping up like this, isn't it? It's X, N, P. Okay? Number of successes, 5 out of 6 trials. Probability of success, 0.85. So let's input that information. 5, 6, 0.85. Calculate 0.3993. Okay, give you the royal guarantee. If you put this in your calculator, it's going to give you the same answer that we generated up here. Okay, get in the habit of making sure we're writing, especially probabilities, 3 significant figures. Okay, so that's the first calculator process we can use. So let's look at BCD. Okay, now BCD, so that was our answer for A. Let's look at part B. Part B says calculate the probability that between 2 and 4 seeds inclusive. So with germination, right, we've got 6 seeds in a pot. Okay, and you could have 0 germinate, you could have 1 germinate, 2. We've calculated this event. That's what we did there. We've got basically a 40% chance that 5 seeds will germinate. Okay? Now, if we want to say what's the probability of between 2 and 4 inclusive, that means it's this event here. It's the probability of 2 seeds germinating, plus 3 seeds germinating, plus 4, okay? And so we could calculate this individually. We could go, well, what's the probability of x being equal to 2? And what's the probability of x being equal to 3? And what's it being equal to 4? And then add all of them together. That's going to give us the probability of this event. Or we can do a BCD calculation. So if we exit out, we're still in binomial distribution, so distribution binomial. Now we're going to do BCD because we're talking about an interval. In fact, what we're calculating is the probability of 2 being less than x being less than 4. Now, inclusive, which is why I've underlined those points. And so what we're doing, our lower boundary is 2, our upper boundary is 4, and then we've got our number of trials is 6, and probability of success 0.85. So let's crunch that one. So 246.85, 0.223, 1. Very good. Okay, okay, C, less than 3 seeds, okay? So I might just shove that B down actually, and this is describing all possible events, isn't it? 0, 1, 2, 3, 4, 5. If it says less than 3, that means 2 or less. Okay, so it means 0, 1, or 2. Now I'm going to show you the other procedure we can use on our calculator. This one's a little bit faster if you can do it, if you can get in the habit of doing it. So C, we're calculating the probability of x being less than or equal, less than 3. Okay, it has to be less than 3, it has to be under 3. Or another way we could write that, because we're talking about discrete values, aren't we? It has to take on a whole number of values. For discrete values, this statement and this statement mean the same thing. Less than 3 means it has to be a whole number under 3. So less than or equal to 2, 1, 0. So both of those mean the same thing. So let's follow along here. We're going to go to our run map. And in here we're going to go option, stat, distribution, binomial, Bcd. Oh, I pressed this. Delete. Bcd. Okay, and then what we do is we enter it in. Well, this is what we're calculating. We're doing Bcd, and this can be a lot faster. Okay, so when you're solving these problems, you will get full marks if you just write the probability. Okay, but I'm going to really strongly encourage you, particularly in a test situation, that you write what you're putting in your calculator, because it's a good way for you to check your answer if you've got spare time at the end, and it's a good way for me to see if you've understood the context and what you're asking. So that's where you can get marks there, or you can even get marked up on performance standards if you're demonstrating the correct thing here and then you don't write it down properly. So I really strongly encourage you to write down the syntax that you're putting into your calculator. Now this is the order you put it in: lower boundary, upper boundary, number of trials, probability. So that's what we're going to enter here at the moment. So our lower boundary is 0. The comma, okay, the comma is just below the cos button, right? Cos, that's where it goes. The upper boundary is 2, comma, the number of trials is 6, and our probability of success is 0.85. Okay, so that's a lot faster. So if you're in a test, okay, it's a lot faster to write this out. So 0, 2, 6, and 0.85 than it is to make this statement. All right. It's also going to be faster to put it in the calculator if you get good at it. So that is, so we've got all the information there. Let's calculate it. 5.885 times 10 to the minus 03. So let's talk about what that means. 5.85 times 10 to the minus 03. Okay, this means, like, I can tell you, oh, we have to bunny hop 3 times. Okay, so you can think about it like that, but I think the best way to think about it is that number there, that's how many zeros. So you go 3 zeros, and then this number, 585, and then you put a decimal place after the first 0. Okay, that's the best way to think about it. This is how many zeros, decimal place after the first 0. Okay, so that's probability of us having 0, 1, or 2 seeds germinate. Okay, D is going to be more than 3 seeds. So in part D, we're talking about this event. We're talking about 4, 5, or 6 seeds germinating. So that's probability of x being larger than 3, which is equal to the probability of x being larger than or equal to 4. Okay, that's the point we're making there. And so that's going to be Bcd 4, 6, 6.85. 0.9526. So always write out 4 figures, round the third. Okay, so we have a 95% chance of at least 4 seeds germinate. Pretty good odds in this pot. Okay, and then part E, find the probability of exactly 3 seeds. E, probability of x being equal to 3. So I've already shown you how we can do that in a stat mode. The same process is going to apply here. We're going to press Bpd because we're talking about an exact outcome. We've got, and this is x and p, that's the input here. So we're going to have Bpd. The number of successes is 3, 6 trials, probability of success 0.85. And this will be the exact same as C63 0.85 to the 3 times 0.15 to the 3. Okay, again, binomial distribution formula. So let's press those buttons. Bpd, and we've got 3 out of 6, 0.85 probability of success. Close bracket. 0.0473.
I didn't get that.
Oh, what did I put in wrong? I pressed Bcd, didn't I? I didn't press Bpd, sorry. Bpd, 3, 6, 0.85. Okay, 10414. 104,145. Yep. Okay. F. What's the significance of the sum of your answers to C, D, and E? Okay, so in part C, we calculated the probability of there being less than 2 seeds germinating. So we calculated this event. All right, probability of this event was quite small, just over 5%, no, less than 5%. In this, it's less than just over 0.5%. In this one, we calculated the probability of 4, 5, or 6 seeds germinating. That's quite high, 95. And then in the last part, we just calculated the probability of 3. Now, the significance of adding all of these together, if we add them all together, it will equal 1. The sum of all probable events is 1. And so we've listed there all the possible outcomes that could occur. Excellent. So that's enough to get into 7G.2. Let's give it a break.